Okay, so we're going to talk about summations today. Like I said, it feels very random, but I promise you there is a purpose. So this guy is sigma. It is used to express summations. Please add this all together. Right? You remember doing series in pre-calculus?
Yeah.
Is that what we're doing?
I mean, yes, but not like we did in pre-calculus. Okay, so let's remember what everything means when we have a summation. Sum. Okay. Here, you're going to have k equals a number. That's where you begin plugging in numbers. And then you're going to have a number up here. That's where you stop plugging in numbers. Inside the sigma, that's what you're plugging numbers into. And then you add up all of those values. That's the sigma. Add them up. Okay, I'll let you write it down and then I'll talk more. So this is where we begin. This is where we stop. Those numbers get plugged into here. And then everything gets added together. Okay? Now, we are going to count by integers. So if this is 1 and this is 5, we plug in 1, we plug in 2, we plug in 3, we plug in 4, we plug in 5, and then those 5 values get added together. Okay? Between like the show choir and the Fortnite, we have a lot of like dancing and singing. You know what I mean?
Bring up Fortnite.
Because I know Fortnite dances because I have you as a student. I'm being very honest.
That's last year. Remember when you caught all of us playing Fortnite together? You, Robert, Sebastian.
I try to like take those things out of my memory. Okay, so don't worry about what's up there. Okay, that's all I said. Okay, we're gonna take our numbers, we're gonna plug them in, and we're gonna add them all together. So go ahead and write down the sum from k equals 1 to 5 of k squared. Well, what does that mean? We plug in 1, we plug in 2, 3, 4, 5. So we have 1 squared plus 2 squared plus 3 squared plus 4 squared plus 5 squared. Are you adding it up for me? Look at that, it says infinite.
Right.
I'm not like really concerned about what the value is, but do you understand why it's 1 squared plus 2 squared plus 3 squared plus 3 squared? Okay. Now the sum from k equals 3 to 8 of 7.
Seven times 5. So.
Yes. Well, 6. 3, 4, 5, 6, 7. Okay, so we plug in 3 to get 7. We plug in 4 to get 7. We plug in 5 to get 7. Do you see a K? No, you don't see a K. So it's just that same number. Okay, our output is 7. no matter what we plug in. But we plug in 3, we plug in 4, we plug in 5, we plug in 6, we plug in 7, we plug in 8. There are 6 sevens. Okay, so that was kind of lame, right? No, you like that one?
Yes.
Pretty simple.
Okay, let's do this one. So this one starts and ends at 3 and 8 also, but it's 2K. So we have 2 times K when we plug in 3. We have 2 times K when we plug in 4. We have 2 times K when we plug in 5. We have 2 times K when we plug in 6. Oh, I don't have enough room. What? Well, somebody said the answer, but I don't.
66.
Yeah. Okay. Notice how this letter matches this letter, right? That's what we're plugging in for. So it doesn't always have to be K. It could be I. I want you to do these two together at your pod. I'll give you 2 minutes.
Pod?
Oh yes, I is a variable. It's not imaginary. We're all real.
49. 2 squared. 8 minus 3 is 5. Plus 18 plus 15. 32 minus 3. 49. Good.
Yeah. I just wasn't sure if we were
So is this
Okay. I saw.
Yeah, I was like, I am eight. No, I knew Well, I don't know. Do you have It's her dad, so I don't know why he does all of his. I think it's up close. Random.
Yeah. Wait a minute. I started. It's
I'm not
like
even.
after the rains in Chicago, you go in class where everyone just knows everyone. It's a little bit awkward sometimes. And I just went.
Oh, wait. What is this?
49.
Yes.
Yes. Minus 1. So I started this week, by the way. Is there something?
No,
Is there something on our calculator for one of these? Or?
Yes.
Sorry.
There should be 49. Yeah. How many of you are thankful you know the unit circle so you can evaluate these quickly?
I am.
Okay, good, good. You know anybody in pre-calc, tell them how much you appreciate it. Okay, they're on that unit circle.
Oh, those poor kids.
No, but that was
Get one of those quizzes like every day. And you're like,
I remember those.
Sine of pi over 2?
I was really good with those.
Sine of pi?
Yeah.
Sine of 3 pi over 2? So our sum is negative 2. Alright. So I wouldn't necessarily write this down, but I just want you to understand what this means if you were to ever see something like this. Okay, so before I had like f of k, instead of writing a function, you might see more of like a sequence. This is how a sequence is notated, b sub k. And so then plugging in 1, 2, blah, 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 all the way to n, we have the different terms of the sequence. Okay? Not a huge deal. I don't think it's necessary for you to write down. But we're going to talk about some properties of our series, our sigma notation. What we can do outside or inside, and how can we like move things around. Okay? This will be important because I'm going to show you some shortcuts. So, if you have a constant multiplied to your sequence inside, it is possible for us to move that constant to the outside and worry about the summation first and then multiply by that constant. Kind of like we do with derivatives and integrals, right? If there's a constant, we can worry about it later. And then the next two are pretty much the same thing, so I'll reveal both of them for you. If you have something added or subtracted inside of your summation, like our sequences here, if we have terms added or subtracted, we can pull that apart to two separate summations. Does anybody need more time to write this down? You are just being kind of a turd.
I didn't witness that. Colby just stole from me.
no respect.
Too bad.
Like 4 inches.
Like a wedding.
Like when I was younger.
You better hope I'm not sick on this day next year, and next year's class gets to hear this entire.
I think you should play it anyway, even if you aren't sick.
Okay.
Take your personal day.
All right, I'll set my calendar for next year. Okay, so using those properties, if we have the summation from 1 to 3 of 2k, we can take this 2 out. And now we have the summation from 1 to 3 of k, and then we can multiply it by 2. So we have 2 times the sum. Now, right now, I know you probably don't see the benefit of doing that because we did a pretty easy problem. But just trust me. What's the issue you have? So for this one, the summation from 1 to 4 of k minus k squared, we could break this up into the summation from k is 1 to 4 of k minus the summation from k equals 1 to 4 of k squared. You will see why that is helpful here in a moment. Okay, so you probably have pushed it out from your mind, but in pre-calculus, at the end of first semester, you learned a proof method called proof by induction, where you proved like these different formulas to be true. Okay? Most of you didn't like it, which is why I say you probably pushed it from your memory. But you proved things like this. 1 plus 2 plus 3 plus all the way to n equals n plus 1 over 2. You proved this last year. I know you did. Okay? Now, I'm not going to go through those proofs this year, but here are, we'll write down these first two. We have 3 shortcuts for summations involving k, k squared, and k cubed. Write them down, please, and then we'll check. So if you have like the sum from k equals 1 to 50 of k, instead of saying 1 plus 2 plus 3 plus 4 plus 5, all the way to 50, we have n times n plus 1 over 2. Is everyone done at least with the first one where I can scroll down? Anyone need me to stay? You'll still be able to see the k squared one. There. This looks familiar, right? Didn't you just write it down for me?
Yep, we did.
Okay. Okay.
Good.
Okay, so if you can remember n times n plus 1 all over 2, you can remember 2 of the 3 formulas, right? The summation of k is just that. The summation of k cubed is what I said, squared. And then the summation of k squared n times n plus 1 times 2n plus 1 all over 6. That's a little bit, but if you can remember these, then it saves us a lot of time. For example, just making sure we're all good to go. Okay, for example, I don't know why I don't have screen shades on any of these. The summation from 1 to 23 of k. Write it down. Okay? Instead of saying 1 plus 2 plus 3 plus 4 plus 5 all the way to 23, we can use our shortcut of n times n plus 1 over 2. Which is what?
Did that one in my head.
I'm impressed. Let's see if you can do this next one in your head. The summation from 1 to 7 of k squared. Instead of saying 1 plus 4 plus 9 all the way up to 49, we can just say n times n plus 1 times 2n plus 1 all over 6.
I got nothing.
140? Okay. That's what you got? Oh. And we'll try k cubed one, just for good measure. The sum from 1 to 6 of k cubed instead of having to calculate all of the cubes, we can just say n times n plus 1 all over 2 squared, which is
41. I actually did that in my head. I'm impressed.
if it doesn't start at 1, the shortcut's not going to work.
Oh.
But guess what? It's going to start at 1. Okay, so what happens if I give you something like this? We could write it as k squared plus k, couldn't we?
Yeah.
Okay, so write down this in its original form. But then we can write it as k squared plus k. And since we know those handy dandy properties, we know that this can be the summation from 1 to 30 of k squared plus the summation from 1 to 30 of k. So using our shortcuts, we have n times n plus 1 times 2n plus 1 all over 6. And then over here, n times n plus 1 all over 2. you have an answer, shout it out. 9,920.
No. Oh, I was gonna say.
He did it without a calculator, but he didn't do it instant. Okay. All right. Last thing we'll talk about is just, kind of vocabulary when you're working in your homework. If you have the shortcut, we would call that closed form. Okay, it's just that one expression. Whereas if you had like the infinite sum, like we do, well, I guess it's not infinite because it doesn't go till infinity. But if you have the sum in terms of n, right, that's open form. Okay, there's a lot of numbers.
Yes.
Okay, it's all of the terms added together. And here's where we'll kind of need this for our transition next week. Don't do that. That's not nice.
Oh.
I wasn't doing it towards him. I was saying, don't do this. Okay, so soak this in here. What's our ending value?
N.
N, thank you.
Boy. Is that not the right answer?
That was the right answer. I was just waiting for people to write things down. Can we use shortcuts right now? What would we need to do?
Factor it out.
Factor would not be the correct word.
I didn't mean factor.
So we have some factors that we need to distribute to
Right.
each other. Okay. So we have 9 plus 6k plus k squared. Right? Okay. So we have the summation from k equals 1 to n of 9 plus 6 times the summation from k equals 1 to n of k plus the sum from k equals 1 to n of k squared. Notice how I separated into each of the 3 different summations for each term. And since I had a coefficient right here, I moved him out to the outside. Okay? Now I didn't do that with the 9 for a reason. Okay? If I'm summing up from 1 to n of 9, what does that become? 9 times n, right? I'm going to add 9 over and over and over and over 9 times. Well, that's the definition of multiplication, repeated addition. Okay? Now here, I have 6 times, we have the summation from 1 to n of k. So this would become n times n plus 1 over 2. I don't care if you reduce that or not, but you could write it as 3 times n plus 1. Okay? And then our k squared. Eli, what's our k squared?
N times n plus 1 times 2n plus 1 divided by 6.
Okay, so there is our closed form. Eventually we'll do something with that, but okay. How's that for a nice change of pace? Huh? Okay, you need to practice this so that you can get familiar with these formulas, because on your quiz on Thursday, you will need to remember those shortcut formulas. Okay?
Oh. And if you forget them, you just gotta grind it out.
Okay. There's an awkward 5 minutes left in class. I would encourage you to get out your quiz, and if you missed any problems, look through that and maybe fix your mistake so that you can maybe not make that the next time. All right. Yes.
This man has AirPods and no There's some kind of a home button either.
It's basically said the same shit.
Honestly, I don't like it.